There are roughly 400 billion stars in our galaxy alone. Scientists estimate that most of them have planets. A conservative fraction of those planets sit in the habitable zone, the region where liquid water can exist on a surface. Even if only 1 in a million of those planets ever produced life, our galaxy should be teeming with civilizations. Some of them would be millions of years older than us. They would have had time to spread across star systems, to build structures visible from across the galaxy, to fill the cosmos with signals so powerful we could not possibly miss them. We have been listening for those signals for over 60 years with the most sensitive instruments our species has ever built, and we have heard nothing, not a whisper, not a single confirmed signal from a single civilization anywhere in the observable universe. The silence is total, and the longer it goes on, the more disturbing it becomes. This is not a small mystery. This is arguably the deepest unanswered question in science, because the math strongly suggests we should not be alone, and the sky strongly suggests we are. Something is wrong with one of those two conclusions. Either the math is broken, meaning life is far rarer than any calculation suggests, or the silence is hiding something about what happens to civilizations over time that we do not want to think about too carefully. Both possibilities are terrifying in completely different ways, and the worst part is that we cannot yet tell which one is true. In 1950, physicist Enrico Fermi was eating lunch with colleagues at Los Alamos National Laboratory, and the conversation turned to the possibility of extraterrestrial life. Fermi listened for a moment, did what physicists do, ran the numbers in his head, and then asked a question so simple and so devastating that it has been haunting science ever since. Where is everybody? He was not asking philosophically. He was pointing at a genuine mathematical contradiction. The galaxy is old enough, the stars are numerous enough, the conditions for life appear common enough. If intelligence can arise once, it should have arisen many times, and some of those times should have been billions of years before us. By now, at least one civilization should have had time to colonize the entire galaxy, even at a tiny fraction of the speed of light, even stopping at every star system along the way. The math shows it would take only a few tens of millions of years to spread across the Milky Way. That is less than 1% of the galaxy's age. So why do we see no evidence of anyone? Why is there no megastructure visible in our telescopes? Why has no probe arrived in our solar system? Why has no signal reached our receivers? The universe had billions of years and billions of chances, and produced, as far as we can tell, complete silence. This contradiction has a name, the Fermi paradox. And in the 70+ years since Fermi asked his question at that lunch table, the silence has only gotten louder. Let us start with what we have actually looked for, because most people do not realize how seriously and how thoroughly we have listened. The search for extraterrestrial intelligence, known as SETI, began in earnest in 1960 when astronomer Frank Drake pointed a radio telescope at two nearby sun-like stars and listened for artificial signals. He heard nothing useful, but the project inspired decades of follow-on work. Over the years, researchers have surveyed millions of stars across a wide range of radio frequencies. The logic is straightforward. Radio waves travel at the speed of light and can cross interstellar distances without being significantly absorbed or scattered. Any civilization advanced enough to build radio transmitters could be detected from enormous distances. We have built receivers sensitive enough to detect a signal equivalent to a mobile phone transmitting from the nearest star, and we have pointed those receivers at the sky systematically for decades. In 1977, a volunteer researcher named Jerry Amon was reviewing data from the Big Ear radio telescope at Ohio State University when he saw something on the printout that made him circle it in red pen and write a single word in the margin: "Wow." The signal lasted 72 seconds, the full duration of the telescope's observation window. It came from the direction of the constellation Sagittarius. It was at exactly the frequency that hydrogen emits radiation, a frequency that some scientists had specifically predicted a transmitting civilization might use because it is a universal constant known to any species advanced enough to do radio astronomy. The signal has never been detected again. Despite dozens of attempts to re-observe the same region of sky with increasingly powerful equipment, nothing like it has appeared. Nobody knows what caused it. It remains the most intriguing candidate signal in the history of SETI, and it has never been explained. Since then, there has been nothing remotely comparable. Not one confirmed signal, not one anomaly that has survived serious scrutiny. The sky has been quiet in a way that, given everything we know about the abundance of stars and planets, simply should not be possible if intelligent life is common. But radio silence is only part of the picture, because an advanced civilization would leave other traces too, and we have been looking for those as well. In 2015, astronomer Tabetha Boyajian published observations of a star now commonly called Tabby's star, formerly designated KIC 84628552. The star was dimming in ways that no natural phenomenon could cleanly explain, not the regular, predictable dimming of a planet passing in front of it. Irregular, asymmetric dips in brightness of up to 22%, which is enormous. Some researchers floated the possibility of a Dyson sphere, a theoretical megastructure built by an advanced civilization around a star to harvest its energy. A partially complete Dyson sphere would produce exactly this kind of irregular dimming pattern. The idea was never seriously mainstream, and follow-up observations eventually pointed toward dust clouds as the most likely explanation. But the fact that the hypothesis was raised and seriously considered by professional astronomers tells you something about where the search for extraterrestrial intelligence has gone. We are not just listening for radio signals anymore. We are looking for engineering on a stellar scale. No megastructure has been found. No Dyson sphere, no stellar relay network, no pattern of stars that has been rearranged by a civilization with billions of years to work with. The galaxy, as best we can see it, looks natural, unmodified, as if nothing with intentions has ever touched it at a scale we could detect. And this is where the paradox starts to feel less like an interesting puzzle and more like something that deserves genuine alarm. There are broadly two categories of solutions to the Fermi paradox. The first says intelligent life is simply rare, possibly extraordinarily rare. Perhaps the steps required to go from chemistry to single-celled life, from single cells to complex multicellular organisms, from organisms to intelligence, from intelligence to technology, are each so improbable that even in a galaxy of 400 billion stars, the chain has only completed once. This is sometimes called the rare Earth hypothesis, and it has become more compelling in recent years as we have understood more about how many specific conditions Earth satisfies simultaneously. The right distance from the right kind of star, a large moon that stabilizes the axial tilt, a giant outer planet that deflects incoming comets, plate tectonics that recycles carbon and drives evolution, an oxygen atmosphere produced by billions of years of photosynthesis. Each of these conditions may be less common than it looks, and if even a few of them are genuinely rare, the probability of an Earth-like planet producing a technological civilization might be so small that we truly are alone in the observable universe, not because the universe does not allow life, but because the full chain of requirements is longer and more demanding than we assumed. The second category of solutions is darker. It says intelligent life may not be rare at all. It may simply not last. This is where the concept of the Great Filter enters the picture. The Great Filter is the idea, developed by economist Robin Hanson in 1998, that somewhere along the path from simple chemistry to galaxy-spanning civilization, there is a step so difficult, so improbable, or so lethal that almost nothing gets through it. Every civilization either never makes it to that step or does not survive crossing it. The filter explains the silence, not because life is rare, but because something stops it. The question that keeps serious thinkers up at night is whether that filter is behind us or ahead of us. If the filter is behind us, if the hard step was something that happened in Earth's past, then we are lucky. The difficult crossing is over. The silence in the galaxy is explained by how hard it is to get to where we are, not by what happens to civilizations after they get there. The origin of life itself might be the filter, or the jump from prokaryotes to eukaryotes, which took nearly 2 billion years on Earth and may have required a highly improbable cellular merger, or the invention of sexual reproduction, which dramatically accelerated evolution, or the emergence of complex nervous systems. Any one of these steps, if rare enough, could explain why the galaxy appears empty even if the conditions for life are abundant. And if that is the answer, the universe is silent simply because we are extraordinarily unusual, not because we are doomed. But if the filter is ahead of us, if the difficult and lethal step is something that technologically advanced civilizations encounter after reaching our current level of development, then the silence is not reassuring. It is a warning. It means that every civilization that has ever reached the point where it could communicate across interstellar distances has subsequently failed to survive, and failed in a way that left no detectable trace. No ruins, no signals from the wreckage, nothing, just silence. What could that filter be? The candidates are not comfortable to think about. Nuclear weapons are the obvious one. We have had them for less than a century and already came within minutes of using them in ways that could have ended civilization during the Cuban Missile Crisis in 1962. A civilization that consistently produces weapons capable of ending itself and consistently chooses not to use them may be a statistical rarity. Most may not make it through the transition. Biotechnology is another. As our ability to engineer organisms advances, the barrier to creating a pathogen capable of causing catastrophic damage gets lower. A civilization advanced enough to develop genetic engineering, but not yet advanced enough, or not yet wise enough, to govern it safely may routinely produce its own extinction through accident or intent, before it reaches the level of development required to become detectable from across the galaxy. Climate disruption is a third. Not because a warming planet necessarily ends a civilization, but because a civilization that cannot coordinate a global response to a global threat may not be capable of the kind of long-term cooperative behavior required to sustain an interstellar presence. The test of whether a civilization survives may be whether it can act as a single coherent entity when acting as one is necessary for survival. And then there are the filters we have not thought of yet. Physics that becomes accessible only at higher levels of technological development and that produces consequences we cannot currently predict. Artificial intelligence that, once created at sufficient capability, pursues goals incompatible with the continued existence of biological life. A fundamental property of the cosmos that makes expansion beyond a single star system either impossible or ultimately self-defeating in ways we have not yet discovered. The most chilling version of the great filter argument runs like this. If civilizations routinely destroy themselves shortly after reaching our level of technology, then the galaxy would look exactly as it does to us. Quiet, natural, filled with planets that got close but never left a mark on the cosmos that persisted long enough for someone else to see. We would be one of those civilizations in the brief window between developing radio and whatever comes next, looking out into a silence that is not emptiness but aftermath. In 2020, astronomers at the University of Nottingham published a study estimating how many communicating civilizations might currently exist in our galaxy using updated assumptions about the frequency of Earth-like planets and the timescales involved in developing intelligent life. Their most probable estimate was 36. 36 civilizations in a galaxy containing 400 billion stars and potentially trillions of planets spread across 100,000 light-years of space, most of them too far away to ever communicate with each other in any meaningful time frame. That number, if anything, makes the silence more understandable, but it also makes it lonelier, because even 36 civilizations distributed randomly across the Milky Way would be separated by an average of roughly 17,000 light-years. A signal sent from one would take 17,000 years to reach the next. A response would take another 17,000 years. Any conversation between civilizations would span tens of thousands of years per exchange. If a civilization only lasts a few thousand years after becoming detectable, the chances that two of them exist at the same time within communication range of each other are vanishingly small. We may be surrounded by the ruins of civilizations that rose and fell while our ancestors were still learning to make fire, too distant and too dead to leave any signal we could receive. There is one more possibility that rarely gets discussed outside of specialized circles, and it is perhaps the strangest of all. What if advanced civilizations are not absent? What if they are simply not communicating in any way we can detect? Our entire SETI enterprise has been built on the assumption that an advanced civilization would use radio waves, but radio is a technology we developed at a specific moment in our own history. A civilization 1,000,000 years more advanced than us might have moved to communication methods we have not yet invented and cannot currently detect. Quantum communication, neutrino-based signals, modulations in gravitational waves, encoded messages in the fine structure of starlight. We would not know to look for any of these things. We would not know how. A galaxy full of conversations happening in a medium we have not discovered yet would look, from our position, exactly like silence. And then there is the possibility that advanced civilizations deliberately go quiet, that surviving the dangerous period of technological development requires reducing your detectability, making yourself invisible to any other civilization that might perceive you as a threat or a resource. This is the dark forest hypothesis, named after a concept in science fiction but taken seriously by some researchers. In a universe where the existence of another civilization is unknown and its intentions are unknowable, the safest strategy might be to listen without transmitting, to observe without announcing yourself. A galaxy full of civilizations, all following this logic, would be a galaxy of listeners, none of them transmitting, all of them silent, all of them waiting, and from inside any one of them, the sky would look exactly as ours does. We do not know which of these explanations is correct. We may not know for a very long time, but the thing that makes the Fermi paradox genuinely haunting is not any single explanation. It is what the silence means, regardless of which explanation turns out to be true. If life is rare, we are a cosmic accident of almost unimaginable improbability. Everything we are, everything we have ever built or thought or felt, exists because an extraordinary chain of unlikely events unfolded on one small planet around one ordinary star. The universe is 13.8 billion years old, and it may have produced exactly one species capable of asking why it is alone. That is not a comfortable thought. It is the kind of thought that, if you sit with it long enough, changes the way you look at every living thing. If the filter is ahead of us, the silence is a map of failures. Every quiet star in the sky is a place where something almost made it. Something developed fire, then agriculture, then writing, then science, then technology, and then did not survive what came next. The silence is not emptiness. It is a graveyard so vast we cannot see its edges, and we are somewhere in the middle of it, still alive, still transmitting, still not knowing whether we are the exception or just the latest in a long series of things that did not make it. Either way, the sky looks the same, brilliant, beautiful, and absolutely silent. There is one detail about our own situation that rarely gets mentioned, and it is worth sitting with before we move on. We have been a detectable civilization for less than 120 years. The first radio waves that could have leaked into space and been identified as artificial left Earth in the early 1900s. Those signals have now traveled roughly 120 light-years outward in every direction. That sounds like a large sphere, In a galaxy 100,000 light-years across, it is an almost invisible bubble. The fraction of the Milky Way that has had any chance to hear us is less than a fraction of a percent. Any civilization more than 120 light-years away has received no evidence that we exist. We are, from the perspective of almost the entire galaxy, still silent ourselves. We have been complaining about the silence for 60 years while producing almost none of it ourselves. That does not solve the paradox, but it is a reminder that we are extraordinarily new at this, and that the silence we are searching through may be, in part, a silence we are contributing to. We are going to keep listening. The Square Kilometre Array, the most powerful radio telescope ever built, is currently under construction across sites in South Africa and Australia. When it is complete, it will be sensitive enough to detect the equivalent of airport radar signals from stars dozens of light-years away. The James Webb Space Telescope is already analyzing the atmospheres of exoplanets for chemical signatures of life. Future missions will go further. We will map thousands of planetary atmospheres. We will listen across more frequencies with more sensitivity than ever before. We will look for megastructures, for anomalous heat signatures, for anything that breaks the pattern of a universe operating purely on physics, with no one home. And maybe, one day, something will answer. A signal that survives scrutiny. A pattern that cannot be explained by natural processes. A response to the messages we have been broadcasting, intentionally and unintentionally, since the first radio waves left this planet more than a century ago. Or maybe the silence will continue, getting louder in its own way as our instruments improve and still find nothing. A silence that says, more clearly with every passing year, that the universe is not empty, but that the path from chemistry to civilization is harder and shorter than we hoped. Fermi asked his question over 70 years ago at a lunch table. We still do not have an answer, but the question has never mattered more than it does right now, in this moment, as we develop the technologies that will determine whether we become the kind of civilization that leaves a detectable mark on the cosmos, or one more quiet entry in the galaxy's long list of things that almost made it. The sky is silent. We are still here. For now, that is the only answer we have. Thanks for watching. I will see you in the next one.